हो गया. Jai Hind. The topic which we are going to cover today is cloud computing. Basically, we are going to cover introduction of cloud computing. So, what is a cloud computing? Cloud basically it is a term which is used as a metaphor for the internet. And what is the meaning of computing? It means any goal or result oriented activity. So basically what is cloud computing? It is storing or accessing the data and programs over the internet instead of your computer hard drive. That is, you are not using your actual system resources, you are using the resources which are residing somewhere else, and you are working on those resources. These resources can be your storage resources, they can be your computing related resources. So in cloud computing, user they do not have a dedicated server, or you could say system basically at his own place. Instead he uses the services or the hardware devices which are being provided by the service providers. Just like your ISP, here the service providers, these are my cloud service providers and they are termed as CSP. For it to be considered cloud computing, you need to access your data or your programs over the internet. So what is the requirement? Internet connection should be there, or at the very least have that data synced with other information over the web. That is, if you are working offline, so as soon as you become online, your data should get synced. According to NIST, what is the exact definition of cloud computing? It can be defined as cloud computing, it is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. Now, what are these computing resources? They are my networks, servers, storage, applications or services that can be rapidly provisioned and released with minimal management effort or service provider interaction. That is, these services, whatever resources you are talking about, they can be easily provisioned, that is granted and released. That is, if you don't want to work them on further, then you can ask the CSP that you are no longer require them, so they are not then your access right is being removed by the CSP corresponding to that particular service. This cloud model promotes the availability and is composed of 5 essential characteristics. Now, these are the characteristics which is basically being defined by the NIST. So, what is the first characteristics? On-demand self-service, then comes my broad network resources, then third is my resource pooling, comes the rapid elasticity, and the last one is my measured services. These are the main characteristics of my cloud computing. Now, the cloud computing, it provides 3 service models, that is SaaS, IaaS and PaaS, which we will discuss shortly. And we are having 4 deployment models, that is private cloud, community cloud, public cloud and hybrid cloud. All these terms which we are going to discuss shortly. So, what are the key enabling technologies behind cloud computing? The very first thing is you should have a very good, or you could say good bandwidth network available with you, and your system should be able to connect with the inexpensive servers. Second important is your inexpensive server computers, and the last one is your high performance virtualization for commodity. That is, the virtualization layer should be there. So, what is the basic difference between cloud computing and your traditional client server computing? That is, in client server computing, you are sending certain request, that is, you are a sender, you are sending something, or you could say you are a client, you are sending something, some request to the server, all being computation etc. being done by this server on your behalf, and once it does all the computation, it will return the result back to the client machine. Whereas in cloud computing, what is happening, the server is providing, that is your host, your machine, the server is providing a virtualized layer of resources to you, and you are working on these resources as if you are working on your individual machine. So instead of sending the request to the server, what you are doing here, whatever you are getting in a virtualized form, you are running your programs, you are storing everything on these virtualized resources and working directly on them. So in the case of the cloud computing, virtualization is the necessary concept. So according to NIST, we have seen we are having 5 services. Let's discuss them one by one. The very first is your on-demand self-service. That is, a consumer can unilaterally provision computing capabilities such as server time and network storage as needed automatically without requiring human interaction with each CSP. That is, as soon as you require certain service, you just send a request to the CSP and CSP will automatically provision you a new virtual machine comprising of the required resources. Another important characteristics is broad network access. As we are aware that cloud concept, the enabling technology behind the cloud concept is your good broadband network. So it is also essential characteristics of cloud computing that you should have a broad network access. So capabilities are available over the network and access through the standard mechanism that promote use by heterogeneous thin or thick line. That is, we are not concerned that on which device we are working or on which device we are connected to. So irrespective of all the heterogeneity of the underlying architecture, we are just working on the servers which are basically meant for or hosted by your CSP, and you are working on those machines with the help of mobile phones, tablets, laptops or workstations. Another important characteristics is my resource pooling. So the provider computing resources are pooled to serve multiple consumers, that is multi-user concept is there, and there is a important concept that is of the multi-tenancy. Just like a room sharing, you are having in a dormitory, you share a room with multiple tenants or multiple batchmates over there. Similarly, here we are also sharing the resources and we used the same concept of the multi-tenancy. Here the multi-tenancy we are deploying with physical and the virtual resources, which are again dynamically assigned or reassigned according to the consumer demand. So there is a sense of location independence, that is, we are not concerned where exactly those resources are residing physically. So we are basically concerned that we want to use this particular resource and it got available to us by the CSP. But the thing is that they have no control or knowledge over the exact location. So this is this become one of the drawback which we are going to discuss shortly, that how it is acting as a drawback. So exact location of the provider resources, but may be able to specify the location at a higher level of abstraction, and these high level of abstraction, it could be defined with the help of country, state or data center. Example of resources include, we have already seen, it could be my storage, it could be my processing, memory, network bandwidth, anything. Another important characteristics is rapid elasticity. What it says, that capabilities, that is the permissions to work on a particular resource, it can be elastically provisioned and released, in some cases automatically, to scale the rapidly outward and inward commensurate with demand. To the consumer, the capabilities available for provisioning often appear to be unlimited and can be appropriated in any quantity at any time. That is, for the consumer, they are not concerned, that is, whether they are using the 20 GB or whether they want to use the 80 GB of hard disk. They just tell the demand to the CSP and CSP they provision that resource or provide that resource to the consumer. Measured service, whatever they are getting, the users they are getting, they need to pay for this, and automatically, just like your electricity billing and all these things, similarly the billing services is also being provided for the cloud computing. So It says the cloud systems automatically control and optimize the resources used by leveraging a meter capability at some level of abstraction appropriate to the type of service. Resource usage can be monitored, controlled, and reported, providing transparency for both the CSP as well as the consumer who is using that service. So, what are the benefits of cloud computing? The very first benefit, it comes the least cost. How? The cloud computing has revolutionized how the business access IT services, infrastructure and software by removing or reducing the need for capital investment and allowing the small scale companies to access what they need when they need on a pay as you go basis, because we are having a multi-tenancy concept and everything is going to be built. So instead of physically buying a infrastructure, it is better to go and rent that physical infrastructure. So it is a least cost. We are having least cost in cloud computing due to the features such as remote upgrades and support. The in-house IT department, they don't require to do any such kind of activities. All such kind of activities being handled by the CSP. Power and capacity, the cloud offers practically unlimited data storage and processing power. This is due to the pooling of computer resources such as geographically distributed servers, whereas before only the richest companies they could afford such kind of resources, but now the small scale companies, they can also afford such kind of services. Backup and recovery, it is very easy. Although the local data backups are still advisable, but the cloud backup offers an easier and the less resource intensive method to protect your data. So most CSPs, they distribute the backups between the data centers in different countries to ensure the reliable access at all times, and also make sure that the data should be made available to the consumer at any time. Availability is ensured in the case of cloud computing. System integration, for many companies, integrating various locally controlled computer systems and apps can be a logistical or headache and consume a lot of in-house IT resources. If you are having your own infrastructure, then no doubt you need a maintenance team. But in the case of the cloud, since the CSP is responsible for providing you the services, so it is the headache of CSP. That is how the in-house activity to be carried out. Next is your flexibility. So change can also be a painful process for locally based IT networks, requiring considerable in-house development and testing if you are going for in-house product or the in-house service, and you need to pay for it. Now these payment, it can be in terms of ID, licenses, etc. In some cases companies are forced to carry on using a system that is not fit for the purpose simply because the cost is very high. So you need to sometimes you want to upscale your system, but since your budget is low, so you can't go for those upgradations. Whereas in the case of the cloud computing, such upgradations, they are being provided by the CSP on a nominal cost. Accessibility, that is, with the heavy lifting performed by the cloud, employees of a company can normally access the applications they need remotely, whereas in the pre-cloud age, they might have needed to travel across town to access a company machine. They can now usually log in via secure password from a laptop or even mobile devices being supported. Speed to the market, that is, many competitive industries, they rely on getting to market quickly before their competitors. So the stakes have now been raised with the growth of cloud. For example, some cloud providers are delivering significant manufacturing IT solutions for their clients by allowing innovative products and services to be deployed and production is scaled up in a matter of weeks rather than months. Enhanced security, although many business owners, they are concerned about the security implications of the cloud, because nothing is at your end, everything is being provided by the CSP. So a compliant cloud service provider is more likely to improve the security. That is, you should go with a CSP who is following all the rules and regulations or the compliances as being stated for the for a successful or for a secure cloud computing application. The economies of scale which apply to computer resources also ensure that best security measures can be put in place with high-level oversight from IT security experts. The most reputable cloud service providers are also committed to complying with data protection measures, particularly since the industry is moving toward the shared liability between data processors and the data collectors. So, whatever security measures need to be deployed, it is being done by CSP, and these CSPs, they need to follow certain compliances to ensure the security of the users, data and processes. A level playing field, how it is acting as a level playing field for SMEs. A major advantage of cloud is that it has enabled them to compete to the big competitors. Otherwise, it is very expensive for them to go or to compete with the big businesses. So competition is now much more about innovation and market appeal, and less about investing a lot of money into starting up a business. It also provides environmental protection. How? That is a large amount of energy required to run the huge server farms and other hardware needed to power the cloud. It may not seem to be environmental friendly, but what is happening? Since the centralization of resources leads to a net reduction in energy consumption, while the smart management of resources leads to less wastage. Hardware is also tend to be located close to energy plants, so it will reduce the transmission losses. Environmental impact of computing can be driven down further by choosing the companies with a renewable energy policy and encouraging cloud service providers to adopt the ecological goals. So, what are the risks or limitations of cloud computing? So, we are having the vulnerability to attacks. Why? Because everything is over the internet. Network connectivity dependency. So, if you are not connected to a good bandwidth network, then in that case you are not able to fully use the cloud resources. Vendor lock-in there, that is upgradation. They are dependent upon the schedule of the vendor instead of a schedule of a particular consumer. Limited control of resources. Limited control of resources is with the users. Downtime, that is challenges due to a technical outages. That is how the consumers, they are going to cope up with the downtime. So, these are all the disadvantages. So, when a cloud is really not a cloud, provided there is some level-headed discussion about the 4 deployment arrangement, then there is a general understanding around information technology experts, if not marketing personnel, that the following scenario don't constitute the cloud computing. What are these? Renting devoted server hardware in a data habitat for a solitary rent. For example, hosting a site regardless of the fact that it is on a membership support. Then server virtualization, running various virtual computers on a solitary server in itself, unless servers might be sent and crushed in minutes by the buyer themselves as opposed to the supplier. Then connecting to your home PC or office PC from any place utilizing remote desktop or VPN. So, these are the few examples where we say that the cloud is not really a cloud. What are the types of the cloud models? We are having public model, private model, hybrid model, community model. What it says, first come to public cloud. Public cloud, they are managed by the third parties which provide cloud services over the internet to public. These services are available as pay as you go billing mode, that is whatever you are using, you have to pay for it. In other words, the whole computing infrastructure is located on the premise of a cloud computing company that offers the cloud service. So, the location remains separate from the customer and he has no physical control over the infrastructure. So, a fundamental characteristics of cloud, public cloud is multi-tenancy, since multiple users are there. So, a public cloud is meant to serve multiple users, not a single customer. Here, the user requires a virtual computing environment that is separated and most likely isolated from other users. So, if you look at the diagram, here we are having the CSP, and this CSP is providing its services to different organization as well as to an individual. Private cloud, it provides the same benefits of public but uses dedicated private hardware for a particular organization. Here it means a cloud infrastructure which is solely by one customer or organization. It is not shared with others, yet it is remotely located. The companies have an option of choosing on-premise, that is you can go with both the option. Either the cloud CSP will come to your premise and host a cloud service over there, or they can host a cloud service at their premise and you can use that particular service after logging on their servers. But on premise it is more expensive, but they do have but in this more secure because you are having a physical control over the infrastructure. So this is an example of the on premise where the cloud server is being hosted within the premise of the enterprise B, and this is externally hosted private cloud where the CSP is having the control of the infrastructure and the enterprise is using that infrastructure, and it is only a single enterprise who is using that server dedicatedly. So in other words, private clouds, they are distributed systems that work on a private infrastructure and providing the users with dynamic provisioning of computing resources. So all the cloud computing concept, they come here. Instead of pay-as-you-go model as in public, there could be other schemes which take into account the usage of the cloud and proportionally billing the different departments or sections of an enterprise. Why we should go for private? Customer information protection, because in private cloud security concerns are less, since customer data and other sensitive information does not flow out of a private infrastructure. Infrastructure ensure SLA that is service level agreement. Private cloud provides specific operations such as appropriate clustering, data replication, system monitoring and maintenance, disaster recovery and other uptime services. Compliance with standard procedures is very easy in case of the private cloud. So specific procedures have to be put in place when deploying and executing applications according to third-party compliance standard. This is not possible in the case of the public cloud, because in the case of the public cloud you have to design a service which is meant for a universal acceptance, whereas in the case of the private cloud you need to design the things or you need to provision the resources according to requirement of a single organization. So you can follow a compliance easily over there. Another important model is hybrid, that is it is a combination of private as well as a public cloud, and sometimes it is also called a heterogeneous cloud. What is the major drawback? That is, private deployment is the inability to scale on demand and to efficiently address the peak loads. Here public clouds are needed. So wherever we are going for this, there is a limitation of the this is the limitation of the private cloud, and if it is hindering your business, then you can opt for the public cloud. So you can opt private cloud wherever there is a demand, and you can opt a public cloud if it is meeting the other demands of an organization. Now what is a community cloud? They are again the distributed systems, but instead of creating for a single organization, here we are creating them for a group of organization or for a group of or for a community. So here they are the distributed systems created by integrating the services of different clouds to address the specific needs of an industry, a community or a business sector. In community cloud, the infrastructure is shared between organizations which have shared concerns or tasks. The cloud may be managed by an organization or a third party. For example, we are having the grids for distributing the electricity, and all the metering and the billing part is done of these services being provided over the cloud. So here we could have a community cloud which comprises of the you could say the electricity distribution of different states. So here it can come under the category of a community cloud. So in other words, community cloud implies an infrastructure that is shared between organizations, usually with the shared data and data management concerns. For example, a community cloud can belong to a government of a single country, or you could say a group of government departments also. The community clouds can be located both on and off the premises. As we have seen with the private cloud, we are having two concepts, on premise and off premise. Same concepts, they also come with the community cloud. So what are the sectors who are using the community clouds? They are your media industry, your healthcare industry, your energy and core industry, for the scientific research. So these are the few industries, or you could say sectors, where you could have, where the community clouds, they are more meaningful as compared to private clouds. Now the things comes how the business is being, models being built around the cloud, because we are talking about the so resources of a system. So we say resources of a system, we talk about the actual hardware, we talk about the platform on which we are hosting the services, or it could be your service itself. So depending upon these category of services, we are having three models: software as a service, platform as a service, and infrastructure as a service. So if we see here, then if we say, okay, we are having all the services available within the company itself, then it is on premise, that is networking, storage, servers, virtualization, OS, middleware, runtime, data, applications, everything is within the premise of a company. When we say infrastructure, so in infrastructure concept, the infrastructure is with the CSP, and above the infrastructure, everything is going to be handled by the consumer itself. So here we are having CSP up to this level, and these services are being handled by a consumer. When we say a platform, that is your the deployment, your development platform. So here comes up to this level, all the things are to be handled by the CSP, and rest being handled by the consumer, that is your customer. Whereas in the case of software as a service, everything is with the CSP and you are just using those services. So very first one is software as a service. Here the business model is chosen by those users who want to use the software or applications provided by the CSP. So the ability given to the end users to access an application over the internet that is hosted and managed by the service provider. Here the end users, they are exempted from managing or controlling an application, because here we we have seen in the SaaS concept, everything is with the CSP. So everything need to be maintained or managed by the CSP. You don't need to worry about it. So thus the end users, they are exempted from managing or controlling the development platform, underlying infrastructure, etc., etc. So the SaaS services are hosted in service provider managed or service provider hosted cloud infrastructure. The end users, they can access the services from any thin cloud client or web browsers. So these are the things you initially required for using those services. Some of the popular SaaS providers include your Google apps, for example, Microsoft Office 365, etc. Whereas in the case of the platform as a service, what we have seen? We have seen that up to the platform part, everything is with CSP. So here, the ability given to developers to develop and deploy an application on the development platform provided by the CSP. Thus, developers, they are exempted from managing the development platform and underlying infrastructure. Here, the developers, they are basically responsible for managing the deployed application and configuring the development environment. Generally, the PaaS services, they are provided by service provider on an on-premise or dedicated or hosted cloud infrastructure. The developers, they can access the development platform either with the help of web CLI or UI, or sometimes with the integrated development environment. Some of the popular PaaS providers, they are my Google App Engine, Red Hat OpenShift, Heroku, etc. And the last one is my infrastructure as a service. It is the ability given to the infrastructure architects to deploy or run any software on the computing resources provided by the service provider. Because you are only getting the infrastructure, so what kind of development environment you require, what kind of applications to be hosted on that particular infrastructure, everything a consumer can decide. Here the underlying infrastructure such as compute, network, storage, they are being managed by the service provider. Thus the infrastructure architects are exempted from maintaining or the data center or underlying infrastructure. But what is the responsibility of the end users? That is for managing the applications and managing the platforms. This is the reference which I basically used for developing these slides, and if you want to study further, then also this particular reference is very good. Thank you and Jai Hind.